I guess time for a small update on the amplifier project. I have finished populating the boards. Well, I say that. There's always something, it seems. So you can see what I talked about in the last video, put in some all thread through here to keep those separated from each other. I actually ended up not using all thread. I had some nylon screws and stuff, so I ended up using that rather than going and buying something. You can see that I finally have one of the caps here installed, and it goes down into there. There would have never been room to actually get that cap in there because I've used a much larger capacitance and higher voltage. These guys came in finally, which is good. Again, they are a higher voltage, and they're tall boys. How tall those caps are, as long as my finger. So those are in. I've got the voltage regulator, 5 volt, or excuse me, 12 volt adjustable regulator installed, and the FET installed for the bias regulator. So that's done. You can see micas and some thermal paste in there. Come back to the FET here in a second. Finally, the rectifiers came in. So that is a full wave bridge rectifier. And some people had an issue with using this as the power supply for mono, or not mono, for both channels at the same time, where they were running KT88s, which draw more current, and they were having trouble with these failing. So they had put a heat sink on them. Now, one of the things I'm doing is, because I'm building mono blocks, I've got 2 of these, so I don't necessarily have the same current draw. I'll have half the current draw that they did. But I did go ahead and put a small heat sink on here. Once I get things powered up, I have a temp probe, probably check that out to see how hot it's getting. I can always go with a bigger heat sink on here. One of the things then that you've probably seen already is I've flashed over to this board. These are the boards I had made by JCL PCB, and boy am I pissed off about it because they constructed the boards without vias. And they're blaming it on me, which of course I'm sure it is my fault. I drew the part in KiCad, I don't know how you're supposed to say it. Imported it into their tool, and I guess you have to tell it that holes have vias. I've never had that problem. I've designed circuit boards. Again, I was an electrical engineer. I've used software to design circuit boards before. I've sent them out for manufacture. Never had a problem where, oh, I didn't know the holes had to have vias in them. I mean, it's, ugh. Anyway, so $50 later, I have boards that I've had to make work. Again, really pissed off about it. I could have sent it back out, but you know, I can make it work, so I did. So what I did, I just went ahead and soldered things to the traces. Of course, there's a pad there, so there was plenty of soldering room, but there's just no via. Not that big of a deal, again, because it is going to the copper of the trace, and so I keep tapping here. These are the ones I decided to go ahead and put in parallel. They are 500 volt, but they're now not in parallel, in series. So they're in series, so they're 1,000 volts, but it does, because they're in parallel, it does have the capacitance. So rather than 470, it's what, 235. But that is then in parallel with this big guy, which is 390. So I've got about 625, excuse me, microfarads there on the output of my regulator, my high voltage regulator for the KT88 anode plate voltage. So again, this was originally a 47 microfarad. So I've got a slow start circuit. This is now more than that. I can't remember exactly what I used, and now I've got it covered up. 220 microfarad. You know, if I was using a tube rectifier, that'd be too much capacitance to try to start. It would fail the tube rectifier because I've got a soft start on the circuit via the this relay here. Soft starts through a resistor there, but additionally there's a thermistor down in here too, which should limit initial inrush current. So this should should soft start nicely with the way this is set up. So it's pretty cool. So this is a separate daughter board essentially, and this will then be mounted so that this capacitor is hanging out of the top of the amplifier to look pretty. I kind of wanted, I probably could have hung all three out the top, but I didn't. I kind of wanted to be sneaky about that for, I don't know, whatever reason. So this will set where you can see it in 2 channels. So each monoblock will have one of these big caps hanging out the top. And then because I didn't have a pad to solder to here on the bottom, because I didn't put vias in the stupid boards, what I did is I ran a wire from the top. I soldered a wire to the top here, ran it through the board, put my cap in, and so there's plenty of, I've essentially made my own via, and though not a hole, I made it with a copper wire. I drilled the hole out a little bit bigger, and then I scraped some of the copper back. You can't see it, but I scraped some of the, oh, you can see it here for where I have the connection. I scraped some of the copper back so I could have more, even more of a landing spot and connection. So that's the capacitor daughter board. I did end up finding a big Phoenix connector that allowed me to solder into the existing holes for that cap, and so this sucker is huge. It's also a high voltage capable. So this is where I will make my star connection for ground. So I like this. I've got plenty of space to put lots of wires in, and so that is going to be a really nice. Again, it's big, it looks weird, but it'll be hidden inside the board. You can see here again where I had to make that correction for the fact that the board was laid out improperly for the FET. And then this capacitor here, or not capacitor, this resistor that you can't see, it's on the other side of the board. I've left these leads long because that sets my bias voltage. Via calculations, I have the bias voltage set for 200 volts, but can change that. I can put more resistance here in parallel and drop that down if it isn't working. You may have seen as I flip this around that I've got a short in here. This is going to be a choke eventually, but for right now I wanted to be able to ohm some things out, so I wanted that short there. So that exists. And then finally, you can see where I've got the output. So this full wave bridge rectifier here, that is rectifying 2 6.3 windings that are in series. So that should be an output of, I don't know, I think it's like 18 volts or so, somewhere around there. That full wave rectification then is DC. By the time it gets over to here, that gets run through this buck converter from eBay, AliExpress really, but I bought mine on eBay, and I will be able then to adjust this buck converter to be the 6.3 volts DC that I need for my filaments for the KT88s and the 12AX7. So that will connect here and run out. It's cool, you set your voltage and current here via these two potentiometers. So again, running this power supply at higher voltage, running it a little hotter in some ways, but because this was designed to run 2 channels, I'm also running it hopefully a little less hot. One of the problems that I do have though is the FET. I was watching a video on the internet about power supply circuits, and they mentioned that you need to be careful about your drain to source voltage, that you don't overdo it, and this FET has a VDS of 200 volts, which isn't a big deal when it's running, because when it's running, it's probably only going to have about 12, 15 volts across it, not 200 volts. But on startup, it will have 200 volts across it, and this is not part of the soft start circuit. So I don't know what I'm going to do. It really, via calculations, it's probably 212 volts across it when it starts, though it does power up through off of these capacitors, which will take a fraction of a second to start up. Will that be long enough to allow the drain side to come up some so that it's not fully 200 volts, more than 200 volts across it? I guess we'll find out. These boards are thick. I don't know if you can see that, but this is not a traditional thickness. Actually, you can maybe see it in comparison to the daughter board here. That is a more traditional thickness for a printed circuit board. These, on the other hand, are quite a bit thicker, which is nice and sturdy, yay, but it does make it a lot harder to unsolder stuff, which is not quite so fun. So, you know, you win some, you lose some. Not real happy about that. I guess I'm going to try it out, because it is such a pain to pull things off of this board that I'll turn it on. If it smokes, it smokes. If it doesn't smoke, great. The final thing I want to show is I bought myself an oscilloscope. So I think I mentioned this in a video that I bought myself an oscilloscope off of eBay. This is small. It's kind of a cool little part here. I'm trying to get the glare off of stuff. It's not really, maybe it needs to go in a package, but it is also battery powered, which is neat. It is just one channel. But hey, you know, one channel of oscilloscope is more than I had before. And not only is it an oscilloscope, it is also a signal generator. So if we clip the probe ground onto there, whee, click the ground probe onto there, clip the read onto there, and it is producing a square wave at the moment. Click auto, boom, and you can see that it produces a nice cool readout of the square wave that it is also generating. The one problem, this is just problems, there's nothing but problems, is this probe, if I recall, is only rated to 400 volts. So if I won't be able to read my B+ voltage with it without the risk of blowing some stuff up, because I should have somewhere north of that, depending on where in the circuit, 440, 420 volts, maybe 460. So luckily though, I do have my Fluke, which is rated up to 600 volts. So I will at least be able to read it, the voltage. I won't be able to look at the signal that's on it if there's any kind of noise. I did buy myself some probes, some hook clips for my Fluke meter. I was super excited about those. They're expensive. They're like 50 bucks. And I got them, and I got excited about having those come in, and I tried to clip them onto the end of my probes that come with the meter. And of course, they don't work that way. It's a little bit like an Apple tax. You have to have the special test leads that the special clip-on probes work with. So another 50 bucks spent later, and I've got that. So anyway, I'm kind of set up. This is about as far as I can get now. Oh, the one thing that I don't have populated though is this. You can see gold still. That is where I've got a it was a different pitch, a different spacing than these, and the original circuit I believe called for a Molex connector. I would really like to have screw on. I haven't bothered to search for that yet, so at some point I may search for that. I'd really like to have things disconnectable, at least on the power side, via these screw terminals. The channel side, the actual amplifier side of things will all be soldered directly. But at least for ease of building, the screw-on is nice. When it comes to the actual channel circuit, though, I don't want the opportunity for noise, and every single extra connection adds the opportunity for noise. When those are soldered, that's a better connection than screw-on, so those will, for the actual audio signal, those will all be soldered instead. So anyway, the iron has been ordered 4 to 6 weeks, they say. It's already been 1 week. My wife was super happy to see that credit card bill come in. But those parts should arrive, and once they do, then I can start wiring things up to power and checking some of this stuff out to see how it actually powers on. Check all the math, make sure the voltages I calculated are right. See if this FET blows up. If it does, if it releases the magic smoke, then I'll have to find a replacement part. I'll have to figure out how to get those off. I have a solder sucker, right? So neat little tool, right? But with these boards, it's really hard to get them hot enough to be able to pull the part off. So and get all the solder out so that you can get something else in there. Anyway, that's it. That's the update for now. And yeah, some people say that the company that I've ordered my transformers from, and again, that's only the power transformer and the choke, I still haven't ordered my output transformers, that anywhere from 4 to 6 weeks for manufacture. Some people say they're as quick as 3. So if so, maybe 2 weeks there'll be an update, but otherwise it'll be a month or more. So hopefully you enjoy my amplifier journey here.